So I mentioned the need for interaction, right? We want to get that interaction going, get that discussion going. So before I introduce my guests, I want to introduce the question of the day, which I will pose to all of you. That question is, what are your top detection challenges? And I realize that's a pretty broad question, but I want to hear your thoughts on this. When you go to detect the latest, greatest, stealthiest incidents, threats, adversaries, anomalies, what are some of your biggest challenges there? And to respond, you can either join through the Slido app, or you can use the QR code that's on your screen right now. Already getting some responses there, definitely on board with the people answer. I think that's a pretty common challenge. So please share your thoughts there. We're going to talk about some of your responses in a few minutes. While we're waiting for that, I would like to introduce my two very, very special guests. I'm super excited to talk to these guys. Really happy that we were able to get them on the episode today. So I'm joined today by Zach Allen and Scott Poley. Zach is with Datadog. I'll let him introduce himself in just a moment. Scott is with Cybersecurity, and I invited both of them to come on the discussion today because I feel that they have a lot to say on detection engineering and threat hunting. He can speak to it much better than I can, but I also just want to give it an extra special shout out to Zach's Detection Engineering newsletter, which I've been subscribed to for a while. If you're not subscribed to his Detection Engineering newsletter, I can only assume it's because you don't know about it yet. So you definitely want to check that out. Scott's got some great resources and some community things that he and his team are working on that he'll talk about as well. But gentlemen, welcome. Thanks for joining today. Was hoping you would take a few minutes and just introduce yourself, starting with Zach. Tell us a little bit about your background and the work that you're doing.
Sure. Thanks for having me, Mark. Hi, everyone. My name is Zach Allen. I'm the Director of Security Detection and Research at Datadog. I mostly run our detection engineering function when it comes to building out how to protect our customers with our security products. On the side, I have a newsletter called Detection Engineering Weekly at detectionengineering.net. And every Wednesday morning, 8:01 a.m. Eastern, you'll get a newsletter in your inbox that talks about the latest articles and the state of the art with detection engineering, as well as like a threat landscape update with news stories.
Great. Thanks, Zach. Scott?
Yeah, my name is Scott Poley. I work at Cybersecurity as a senior threat hunter and content developer, where I basically am studying adversaries to figure out how they work and then coming up with unique ways to use technologies that people already have deployed to find and detect them for post-exploitation specifically. My background, I've probably been in cybersecurity for about 15 years. I had the fortunate opportunity and the stress for standing up a security operations center and building that out from the ground up, which was a fun exercise. But we had a lot of success there. And I'm just love everything cyber. So it's kind of my passion. It's kind of why I enjoy being on here. Thanks again, Mark.
Yeah, absolutely. Excited to dig into it. And for those of you who are less familiar with detection engineering as kind of a formal SOC discipline or security operations discipline, this is, there are a lot of ways to describe it, I think, but maybe the simplest way might be, take what you know about a threat or an adversary, and we want to kind of translate that into a detection, right? And how you do that, I think, varies. That's what I want to talk with both of you a little bit today. The level of rigor and formality in that process and how it connects with other kind of functions in the SOC. I think those are some of the things that differ from one team, one organization to the next. So I guess while we wait for those last few responses on the Slido poll to come in, what are your thoughts? And I'd like to hear I'd like to hear from both of you on this. What are your thoughts or recommendations for teams that are just looking to get started in detection engineering, right? Like, I've got tools in place, I've got people to operate the tools. Maybe I'm writing a few custom rules or tweaking things here and there, but I want to make that more repeatable and more formal. Like, how do I get going? How do I get started?
Sure, I'll jump in on.
Actually, Scott, go ahead, please.
All right. Yeah, so for me, and especially in an environment, I think what's really important, there's always great resources out there. Like MITRE does a great job with behaviors and tactics that adversaries use. But one of the things I think is commonly overlooked is understanding your own environment and processes. If you're just starting out and you have the tools and technology, I feel like there's a lot to be gained. For instance, just an easy example, if you're looking for when accounts are being created, well, what is the internal process for creating accounts in your environment so you can actually identify those anomalies? So you can kind of keep things simple when you start really understanding your environment and your data as you're kind of getting off the ground. And I feel like that's kind of a great way to get a lot of good returns on some basic, simple things. It doesn't require a lot more work than really trying to add more advanced type things you can do.
Mhm. That's great. Zach, what do you think?
Yeah, I think Scott has nailed it here. There's a lot of things you can do with detection engineering, and you kind of want to roadmap it out in a sense of starting small and expanding outwards. I always tell people that this concept itself is about scale. And so it's measuring where you are now and where you want to go, and what tools, technologies, and people do you have available to kind of implement it. If you want to go and check out, there are a few resources. One's by Kyle Bailey, detectionengineering.io. Uh, this is a maturity matrix that Kyle wrote to kind of showcase like, hey, if you're just starting out, try to hit these things first. And then as you mature, here's some different ways that you can get a better process in place for your detection engineering program. Other resources, Heider Dost from Snowflake. He did something similar where he filled out a maturity matrix and says, if you focus on people, technology, and process, what's like your crawl phase, what's your walk phase, and what's your run phase? And so you're always kind of looking back at one of those three things, right? People, process, and tech. And I think it really depends on what stage you're at. But what's nice about it is that you can kind of take what you like and take what makes sense and kind of start building from there.
Great. That makes a lot of sense. Yeah, anyone who's taken my LDR 551 class knows that like I'm a huge fan of maturity models and frameworks. Like if someone else has created it, that's fantastic. I don't have to create it. I can just use what's there. So I appreciate you calling out a few examples of those. And definitely agree with Scott's comments, understanding your own environment. We don't immediately have to worry about threat intelligence and feeds and everything that's out there. We can start by just spending time studying what we know about our own network, our own systems. 1000%. And I'm really happy that you brought that up. Let's pause for a second and go back to our Slido poll. I want to see what some of our audience has come up with in terms of challenges in detection. This isn't necessarily specific to detection engineering, but I think the three of us and probably many of the folks in our audience would recognize a lot of these challenges. So let's see, we've got resources, staffing, lack of skilled experts who have the time as well as the skill set to do this kind of thing. What else do we have? Misconfigurations, false positives, too many alerts to deal with. So that's something that I think plagues most SOC teams, right? Too many alerts. How can I pause that or step away to write better alerts if I'm already underwater with the alerts that I have? That's a pretty common challenge. I see some kind of vendor management, making sure you're getting value from your partners who are providing this. Interesting. Any surprises here from you, Scott or Zach?
No, I mean, I feel like I've heard the same role before. Yeah, I mean, the big thing for me that always stands out, and that's the false positive tendencies, right? Because I feel like detection engineering, one of the main goals is to have that high fidelity so that it can be more operational and not just kind of responding to the kind of noise in general. So that's a big one I've seen a lot of places.
Mm-hmm. Mm-hmm.
Yeah, I think for me, the lack of resources, understaffed, that's a huge question to answer. And I think I said earlier, to me, it's all about scale, right? And what I've seen successful detection engineering programs implement are concepts from other parts of tech. So specifically software engineering, DevOps, site reliability engineering. And what's funny is that these places and these professions already kind of face these problems of being understaffed. And what they did is they started creating different ways to kind of tackle these problems at scale. And so I always tell folks, like, when you think of detection engineering, I think of it as like a three-legged stool. We have our security subject matter expertise that's critical, making sure we know what the threat landscape is. But the two others are statistics and software engineering. And picking the parts that are the best from each one of those and putting them together, you can start to see like a clearer picture on how you could take a smaller team and really expand it out and make it do the work of a much larger team.
Interesting. I like that. I like the three-legged stool. Love a good three-legged stool analogy, no matter what. But that's I really like.
I can't do four-legged stools. It's too much to remember.
It's too much. That's just unreasonable. But three-legged stools, for sure. So, kind of related to that point, you mentioned having a smaller team do the work of a much larger team through some of these repeatable processes and having the right elements. One of our audience had an interesting question here. I'm an IT support engineer in a small company. How can I implement an open source or free tool for detections? How can I implement them? And I think this is a pretty common challenge too, because of course we're talking about security operations teams and making this a formal discipline. But if you're a team of one or a team of three and you're kind of doing everything, how can you kind of focus on having good detections? Interested in your thoughts on that. Do you have any recommendations for small teams who maybe will never have a dedicated resource, maybe can't pay for an MDR or an MSSP? Is there anything that they can do to get better at detection?
I mean, I'm familiar with people using Elastic Stack, right? Kind of a good community tool. It has the abilities to let you at least look at your data, centralize your data, which is a good common first step for if you want to operationalize anything, right? But you also are able to then have some basic detections. They even have an endpoint that kind of rolls with that as well, that lets you kind of get some defense as well as alerting associated with it. So yeah, I'm a big proponent of like using GitHub for a lot of really cool tooling and solutions for things. So obviously being active in the community, looking for resources where people are trying to solve similar problems. Usually I come up with some interesting solutions as well. So.
Yeah, absolutely. Right. And one of our audience also said, don't reinvent the wheel. So definitely agree with like using community resources wherever you can. Good. And we have some other folks kind of chiming in with some other free resources, other community resources. I think that makes a lot of sense. Definitely. So, we've talked a little bit about like getting started and some of the challenges. And I know both of you have spent a fair amount of time working on this problem set, right? It's making detection better, tying it in with other functions. What would you say are some of the mistakes that you commonly see with teams that are trying to do detection engineering or trying to improve their detections? What are some of the pitfalls there, Zach? Let's start with you. Any major issues that you run into quite often?
Yeah, it's a great question. I think some of the fundamental things that I've seen kind of go wrong in this field is thinking that more is better. And what I mean by that is taking on a lot of rules at once and feeling like you have this concept of good coverage. And basically what happens is you start getting runaway alerts. I think Scott talked about false positives earlier and on how critical they are and how detrimental they can be to a team. So to me, I think, teams that are just starting, select a core set of problems that maybe your business wants to prioritize. Top 3 things. Figure out how those map to data sources. They could be auth logs, it could be email sign-in logs, and just start small. Start small and expand from there. It's a lot easier to do that than it is to start big and then bring it all the way down to something that matters. And I think if you kind of take that approach, it's iterative and you're able to take on more work and make decisions on that a lot easier than trying to manage all kinds of alerts from all kinds of data sources and all the problems that come with it.
Mm-hmm. Good. Yes. Scott, what do you think? Major mistakes, pitfalls?
Yeah, so I feel like trying to solve everything with the detection can sometimes create a problem, right? And that, I think, lends itself to some of the false positive natures. Like there are just some common activities in your environment that maybe coincide with kind of behaviors or things you want to detect from an adversarial perspective, but it might not be advantageous to make an alert you have to respond to every single time. So, it's good to kind of divide up that work where maybe you have detections that are your higher fidelity things that maybe you can even automate some sort of response or enrichments to, or put in front of an analyst, versus you have some reporting, right? That you kind of have these daily or weekly, whatever you want the reports to look like, that are more your false positive heavy type things that kind of give you an idea of what's happening in your environment. And maybe that also could suss out things that make and mature that detection, so it could be more of a real-time capability. As an example of keeping things simple too, is one of the best detections that I think we created in our SOC back in the day. We just called it chained authentication, and it was on the premise of, if an adversary gets in your environment and has one set of credentials, they're going to try to move as far as they can with that set of credentials, likely, right? And so all we did was basically say, if we see a network login going from one host and then we see another one chaining off that host to another host, it's worth looking into. And I want to say, even to this day, it's still catching pen tests. And it's just a very simple idea. We're not focused on how are they authenticating, how they are stealing things. And sometimes just kind of keeping it simple, understanding what it is you're actually trying to identify, can give you more returns than those really advanced techniques that people use, along that chain. And that's why we call it a chain, right? You don't have to get every single piece of it, but once you identify certain links, incident response becomes very successful. And as far as tracking down all those other pieces, so.
That's good. Yeah, I like that. And I think I've probably said that many times to clients and students alike, which is, detect the links, not the chain, keep it simple. Don't try to do too much. Don't try to, boil the ocean, so to speak. So I'm glad, Zach, that you pointed that out. And I always, from my military days, we used to say slow is smooth and smooth is fast, right? So before we worry about doing all the things or doing the things super quickly, let's focus on doing them reliably, repeatedly, few mistakes, and I think that applies to detection engineering as well. But really good points. Just going to some of the audience comments and questions. I see we've got some additional kind of resources in terms of open source projects and frameworks and standards. I see Yara, I see Velociraptor, Security Onion. These are all in the chat. Great resources to check out if you're trying to play around with or get started in writing your own detections. Question about detecting traffic going through split tunnel. And if you're not familiar with that phrase, you've got, especially these days, a lot of users that are connecting in through a VPN to your corporate network. But depending on the configuration of that VPN, they might have essentially a doorway into your network, but they also have a doorway at home through their wherever they are, their home connection or wherever they're working from. So they can also go directly out, to the internet that way as well. Hence the term split tunnel. We can go either direction. And effectively what that does is kind of bridges an untrusted, unknown network with potentially your corporate network. And I think one of the reasons I wanted to highlight this question, even though it's very, very specific, is how do you detect a thing that you can't even see? And back to Scott's point earlier about understanding your environment, how do we overcome these gaps? If I don't even have the data or the visibility, how can I write a detection for that? How can I, come up with some kind of way to see that? So whether it's split tunnel or another kind of gap in your visibility, what did the two of you tell internal stakeholders or clients about these kinds of gaps? Hey, I know this is an issue. I want to detect this attack, but I actually don't have the data. Aside from the obvious answer of, well, maybe get the data. What do you say to something like that in those situations?
Yeah, for me, I kind of fall back on the chain of things, right? For one, you're kind of looking at, okay, there's a lot of steps in an attack, and then a lot of those steps are kind of repeatable, right? It's not so much linear as attacks really occur. So yeah, you're going to have some blind spots, and sometimes that's just the nature of what tooling you have. Sometimes it's the nature of cost, right? If people aren't going to throw money at everything, so you have the visibility of everything. So as long as you're really focusing on those key points that you expect adversaries to fall over, essentially when you think of detections, they're really just tripwires you're putting in different places, right? And so what you have to be able to explain is based on where you have visibility, you have tripwires in line. So if someone were to get around certain tripwires, you have other tripwires they might stumble on. And then just for your example of the split tunneling, I've seen some interesting solutions as well, where people just created some basic PowerShell scripts that like scrape the history files of browsers and then had that push out to data collectors to be able to see the activity locally on the host as far as where they're actually going, what's going on. So if you have the time and the resources, you can also kind of engineer around that as well. But just know there's cost with homegrown solutions. So, but there's things that you can get creative and it can be fun, but understand that the time and the resources it take.
It's all a trade-off. Right?
Yep.
Zach, anything to add to that? Accounting for visibility gaps when you're writing detections.
Yeah, I love Scott's analogy of a tripwire here, and I think to kind of double down on this too, especially when it comes to something like you're worried about exfiltration and it goes through split tunnel. Instead of just focusing on those tripwires in the network, you can provide more of defense in depth on the resource itself. So, for example, if you're worried about source code leaving, or if you're worried about certain sensitive documents, like from a file share leaving the network, you can add additional controls on top of that. And through there, that's when you can find those additional detection opportunities, or that tripwire, Scott said. I'm stealing that, Scott, so I'll make sure to attribute as much as possible.
No worries.
Good deal. So yeah, and I think those are all great points, right? It's it's always a trade-off, spending time and resources to detect maybe the initial vector or some really complicated fringe use case, maybe less attractive than looking for maybe you kind of accept detection later in the chain, but maybe you'll catch more sophisticated types of threats or different types of attacks that way. So that's great. Questions keep coming in. Please keep them coming. These are great questions, great comments. There's a question about using like block listing or allow listing. And I'm going to pivot off of that question a little bit and just say that my favorite kind of detection problems are the ones that I don't have to solve. If I can shift something to a preventative control and just like get out of the business of having to go look for that thing all the time, fantastic. So any utility like Windows App Locker or anything that can restrict actions, and then I can sort of maybe not ignore it, but take it off my plate. I think those are great. So yes to allow listing or block listing, those kinds of things. So let's see, another question here about Sigma. And I wanted to highlight this question because there are some really great projects out these days for blue teamers, like Sigma. Yara, of course, has been around for a little while. Jupyter notebooks are making kind of a big splash in Infosec now. These are all open source projects designed to standardize analytics so that I can write a Sigma rule, and theoretically I can use that same rule logic in Splunk. I can use it in QRadar. I can use it in Elastic. Whatever I happen to have. So there's a question about what are your thoughts on utilizing Sigma rules? Do you utilize them? So let's start there. Do either of you utilize Sigma or any of the other tools, Jupyter, Yara, all of the above? If so, why? If not, why not?
Yeah, at least on my team's side, open source is super, super important. And it's just a really great way to kind of get started on a specific problem. I think, Phil Venables wrote recently about industrial versus artisanal security solutions. And to me, open source is like approaching industrial, which means that it's standardized. We can take it, bring it in, and we can kind of jump ahead by 80%. And then we have to finish that last 20%. And so the way I would suggest users to implement Sigma is, again, don't take the whole thing and deploy it. Instead, pick things that you like and begin that tuning process. and make sure it matches kind of like with the business objectives there. I think without Sigma, it would be a lot harder for all of us to do our job, and especially in the vendor space, because you see a lot of the backlogs and a lot of the inspiration on vendor-based detections come initially from Sigma. And it's that open source mentality that I think is helping protect a lot of people.
Yeah, I would agree. I love Sigma. One of my favorite things about Sigma that you kind of see a lot in our industry in general is it kind of standardizes some things, right? It gives us a kind of a common language and it breaks down that learning barrier where maybe you're not familiar with how to write rules, but if you learn Sigma, you kind of understand the logic that goes into a rule and what may be required in a rule. But I think one of the pitfalls that some people fall into when they just solely rely on Sigma is not understanding their own tool sets, right? So I think Sigma, like you mentioned, like the 80-20, like I think it gets you 80% of the way there to help build the filtering you need in a detection. But there's some great transforms or aggregations or things you can do in your tools to maybe increase the fidelity, or you may be able to pin that to something else to make a more reliable detection, or focusing on a more specific problem. So I would definitely people that if they do rely on use Sigma, don't forget about what their tools are actually capable of when they're trying to import or port those types of detections in. So
fantastic. I love these answers. So much better than any answer I would have given to that question. And very diplomatic, right? It's not 100% solution, as things often aren't in InfoSec, but I really like the 80-20 kind of logic there. It's great for sharing, great for standardization, and it gets you there much faster, but you still have to think about what your tool capabilities are and how you can get it the rest of the way. So that's awesome. I love that. And if I could just kind of like record both of those answers and then dub AI over when you said Sigma, I think maybe the answers might be very similar, because there's another question here from a member of the audience about how do we leverage AI, artificial intelligence, in detection engineering? And I can almost hear everybody's collective like heads explode or like melt when they hear AI. The groans. But I don't know if either of you are doing AI or any kind of automation in detection engineering today. But I guess to broaden that question slightly, how are the two of you using more advanced technologies, whether it is some kind of more advanced automation or maybe AI, ML, those kinds of things? Are you using any of those in detection engineering? Are we not quite ready for that? What do you think, Scott? Start with you.
yeah, so I kind of have two takes. One, I don't think AI and ML is the magic bullet, but I think there's a lot of things it does really well, because really what it is just advanced statistics, right? So when you have an environment that doesn't change that much, then it's really good to catch outliers and anomalies that way. And that's how I kind of picture the best capability of AI. I know they're building models and integrating more models together, and it's going to be a more stronger solution. But today I still feel like it kind of sits in that realm. Secondly, how do I use AI? So I'm a big proponent of ChatGPT, but mainly for emulation, like creating emulations for types of attacks that I wanted. We haven't really touched on emulation, but I think emulation is very, very important, because sometimes when an advanced problem comes your way and you're able to figure out how to at least emulate the data to see how your tools can detect or see that type, then you can understand the data around it and build better detections that may not be as obvious. So I remember back in the day when I was looking at DNS tunneling as an example, and I was thinking, this seems like such an advanced attack. Like, how does someone leverage this? And they can get around all your defenses by using, public DNS infrastructure and things like that. But then when I was able to emulate DNS tunneling, it was very obvious when I looked at it what DNS tunneling looked like. It was a ton of DNS requests, a ton of different random subdomains to a common domain. And there were obvious patterns in there that if I didn't look at that, I'd still be kind of stumped. Like, well, it seems like a very complex problem. So I think when I use ChatGPT to help me code some things, that's kind of how I leverage that for emulation purposes and help solve those kind of what I would say would be complex problems.
Mm-hmm. Okay. Yeah, Zach, what's your take on AI automation? That's a good answer, is to say it's basically statistics. It reminds me of that. What does that mean? Where like Fred from Scooby-Doo like rips the mask off, and
Yeah.
it's AI ML, and he takes the mask off, and it's statistics underneath. What are
Yeah.
your thoughts, Zach?
AI and ML is just a different positioning for statistics, but basically, what I've seen it be very successful on, Scott was touching on, is baselining. And so, how can you describe what's normal, and then using AI and ML to do like a continuous prediction of what's outside that baseline? I think a great example of this is impossible travel. Somebody's usually logging in from New England, then all of a sudden they just logged in from Russia, and there's no aircraft in existence that can transport that person that quickly to go and log in there. And so that's one example there. We're using AI and large language models at Datadog, and it's been particularly useful for summarization. And so you have a huge page of like logs or just a massive search result or an incident with a ton of different work streams going on. You can ask a large language model for that summarization. And I'd like to see more of that when it comes to building detections. Like you issue a query or you get a list of true positives and false positives. Ask ChatGPT, hey, what do you think this is? How would you split this up? What's legitimate? What's not? The other one that I've seen, and I've talked with several detection leaders, is they're using it for translation. And so taking something that maybe, so Sigma has their backends, their Pi backends to go from Sigma to a different search query language. But if you don't have that backend, how can you do that one-to-one conversion? And I've seen a lot of folks use large language models to do that conversion and then implement it in a way such that they'll run the rule in the source language, translate it, run the rule in the destination language, and then compare results. And if they're good, they'll ship the detection into production with the new query. So I've seen those two things be used pretty successfully here.
Great, great examples. And quick time check, we have a little bit less than 5 minutes remaining. And unfortunately, I don't think that's going to be enough time to get through all of the great questions and comments we still have in the chat. I think kind of one thought that is relevant to some of the comments and questions that I'm seeing is, when you are creating new detections, regardless of how formal your process is for doing that, I think it's important to remember that you're essentially creating more work, and you're creating work downstream. So, we've talked a little bit here today about emulation. Scott, you mentioned the importance of testing and emulation. Zach, you just talked through a couple of examples where you're doing testing. You're kind of enriching the data as much as you can. And I think all of those things speak to arming the analyst or whoever is responding to that alert with as much information as possible and as high of a quality of alerting as you can, because you're creating more work for them. And as we've already discussed, as we've already heard from our audience, having time and resources, that tends to be one of the largest challenges. I think in our word cloud, that was the biggest one. So just kind of a parting thought here. While we're on parting thoughts, I'm sure we could talk about this all day, but Zach, we'll start with you. Any parting thoughts? If I said, what's the most important thing I need to know about detection engineering in a minute or less, what would you tell me?
It's a great question. I'm going to lean back. Yeah, it's okay. It's okay. I'm going to lean back on it's a scale problem. And the scale, as Scott talked about in his first answer here, it just really depends on your environment and how much you want to take on. So start small and expand, and think about those maturity models, crawl, walk, run. I strongly suggest that you don't jump right in and take on as much work as possible, because it can get really messy really quickly. And so making sure that you could be iterative and show quick wins in the long run pays off a lot more than trying to get something massive started from day one.
Okay, good. Scott, how about you? Yeah, I would say to kind of boil it down and to kind of harp on some of the things you were having with the lasting remarks there is, keeping it small and simple, to get good ground early on. And then when you spend time for automation, don't spend so much time on the response part, spend more time on the contextualized part. I really feel like if you're able to automate some contextualization, then you can make your detections better, or at least make your responses to your detections better. and you can get a lot of runway that way as well.
Okay, great. About a minute and a half left. Scott, anything that you want to highlight or plug in terms of resources for the community or things that you're working on that might be of interest to the audience?
Yeah, so we have a lot of free resources at Cyborg Security that kind of go into like actual workshops, hands-on things for threat hunting, which I think is really good. We also host a podcast. It's Out of the Woods Threat Hunting Podcast, where we just want to get, and it's not seasoned professionals. We like really new people to come on, and we like to interact kind of similar fashion here. And we really talk shop security and focus on threat hunting, and also touch on some of the top stories every week. So, yeah.
Excellent. Good. Zach, how about you?
Yeah, if you want to check out some more detection engineering resources, I run a newsletter. I plugged it at the beginning of the podcast, detectionengineering.net. It's called Detection Engineering Weekly. And I also run the security labs team at Datadog, and we try to publish a lot of very technical topics and blogs on this topic, plus a lot more. And so securitylabs.datadoghq.com is where you can go find it. And we're trying to publish as much as possible and give those resources out so we all can get better together.
Outstanding. Outstanding. Thank you. Yes. +1, go subscribe to Zach's Detection Engineering newsletter. It's fantastic. So before we go, one final thing that I want to plug, two things actually. I mentioned that I'm the co-author of LDR 551, Building and Leading SOC Teams. My co-author, John Hubbard, and I just completed in the past couple of weeks a pretty major update to the course, new labs, completely overhauled Cyber 42 simulation game that we play in the course. So, we talked about detection engineering, but in this class, which is 5 days long, we talk about everything from building your team, staffing, to collection, detection, response, continuous improvement. Many of the topics we mentioned today, like adversary emulation, measurement, maturity scales, building the right culture, training your team, all of these things and more we cover in LDR 551. So if that's of interest, definitely check that out. I also want to call out the SANS Detection Engineering Survey, which is, I believe, still live. We posted it a couple of weeks ago, and that's out there. We've published this detection engineering survey to kind of take stock of what some of the common challenges are, some of the things we've discussed today. And of course, as with the other SANS surveys, we'll be releasing that data set when it's ready. But I highly recommend checking that out and contributing to it, responding to the survey questions if time permits. So with that, that brings us to the end of the episode. I want to thank my guests again. Zach and Scott, thank you very much for joining, for sharing some of your thoughts and your time. Want to thank the SANS staff, Thomas, Stephen, Michelle, Brett, everybody behind the scenes. Thank you very much. And thanks to all of you for your comments and input and questions. Have a great day. Have a great evening. We'll see you next time.